a rectangle. Okay, now, okay, so we got a plane. If you take those 4 verts of that plane and you subscribe the plane up within 3 dimensions and you give it a height, now you have a cube. Or you have a, you have a cube. I'm going to use the term cube. A cube means all equal sides. But the point is, okay, I got it. You have a cube. If all the sides are equal, you have a cube. If all the sides are not equal, then you have a 3-dimensional object. A 3-dimensional object cannot have any less than 6 verts to be recognized as a 3-dimensional object. The reason why is because the simplest 3-dimensional object, the simplest 3-dimensional object in our universe, in our space, cannot have less than 6 sides. It cannot have less than 6 verts, and it can't have less than 8 verts and 6 sides, and to be recognized as a simple poly in our universe. That's the fundamental truth. You can try to prove that wrong. I would love to see if I'm right, but that should be a fundamental truth. You should not be able to subscribe a 3-dimensional object, a true 3-dimensional object. That means you can have 2 planes side by side, and you can call that a 3-dimensional object, but the planes themselves are just 2 planes side by side. The planes themselves don't have any height. If they're true planes, they have no height. If you subscribe to 2 planes with height, then you have 16 verts, and you don't have the simplest object. So check it out. It'd be cool to see if that's accurate. But keep trying to stay focused on the topic. Right now we should have a cube. We should have a physical 3-dimensional object, the simplest object in our universe. A geometric object has no fundamental forces or abstract attributes such as mass, gravity, magnetism, temperature, light, darkness, etc. This is why I'm using 3-dimensional programs as a foundation, because you can eliminate all that stuff. For instance, me as an object, I'm comprised of the chemical elements. The chemical elements being those associated with the periodic table. But my geometry is separate from the chemical elements themselves. The space that I take up can be described as an abstract concept, void of any dynamic forces or physical matter or energy. That is what I mean by dimensional coordinates. When you eliminate all of the matter, energy, or physical forces in our universe, in our space, then you are left with empty geometry. Empty geometry is dynamic coordinates because you don't have a reference point. For instance, I'm sitting here describing to you a cube that you can in your mind visualize, but there's nothing actually here in front of me. That is dimensional coordinates. That is the abstract concept that I'm going to address, because it is that abstract concept is what our universe is comprised of. Our universe is comprised of empty geometry. We, as human beings, as creatures of mind, body, and spirits, literally describe the actual geometry. We give rise to it by recognizing its existence without evidence of its existence, and that is the beauty of mathematics, because math allows us to do this in a very accurate, abstract, reliable, measurable, repeatable way. So, what is the difference between static geometry and dynamic geometry? The difference between static geometry and dynamic geometry is when you have a coordinate. Let's say you have a vert, and the vert is in a location, is on a Cartesian plane at a location location x0, y0, and z0. What you have is a static geometric location. You have a vert that is located at rest with 100% absolute potential of location 0. 0x, 0y, 0z. That is an absolute location. It's static. It doesn't change. It's always the same. It's constant. If you had another object on the same Cartesian plane in relationship to that particular vert, you can move that object around relative to that position and always use that position to check yourself, to check and determine where the location is at. A good example of that is the North Pole as an absolute location of the Earth. The North Pole in relationship to the Earth itself never changes. is constant. So it's south pole. They are constant locations on the Earth. They exist at a specific length, width, and volume location in relation to the Earth. The actual surface of the Earth being described as longitude and latitude coordinates of a sphere, because the Earth is a sphere, or at least I believe the Earth is a sphere. You know for a fact that the location of the North Pole is absolute, and you can measure the distance you travel in relation to where you was to where you're going in relation to the actual location of the North Pole will give you an absolute location. So the North Pole is an abstract. The North Pole is an abstract static dimensional coordinate. It never changes. If you're on a boat in the ocean, your position is constantly changing. You have very limited control over the ability to stay stationary relative to the location of the North Pole as a repeatedly measurable static dimensional coordinate associated with longitude and latitude dimensions of the planet Earth as a globe. In the same way, in the universe, you can say that the sun is a location or coordinate that is an absolute location. The prime meridian line, I hope, is another example of what I'm suggesting. The prime meridian, if I'm using the word correctly, is the location on the Earth at zero latitude. Zero latitude on the prime meridian, which I believe runs through a European nation, is the location on Earth where we decided that this is going to be the 0 point of travel. The reason for this is because if an airplane, or if you're trying to traverse the Earth globally, you need a location to start with. You have to have a position to measure yourself from, because you can't always measure yourself from your center. It is a very fundamental and widely accepted idea that you are the center of your own universe, which is true to a degree. The problem being the center of your own universe is you're constantly changing. How can you find your location if you are your location? How do you find your way back home if you are your center? You have no way to navigate your surrounding. If you say that your home is your center, when you move relative to your home, you know how to navigate back to your home because your home is a constant. But when you're your center, you are a dynamic. You are a dynamically moving 0, 0, 0, 0, 0, which is too abstract to be observable and repeatable. This is why I subscribe to existence being static dimensional geometry, because the universe, as an abstract concept of a location that is absolute with no changing variables in its dimensional coordinates, gives you a reference to measure the universe against. Because if the universe is in motion relative to static geometry, you can understand that. You can perceive that in your mind because you understand that somewhere in the universe there is an absolute 0 location of infinite coordinates. X, Y, and Z being length, width, and depth, being 3 dimensions, and the existence can be infinite. That means you can subscribe one coordinate as an infinite magnitudinal value into infinity, where number 1 is as a value can be a coordinate. Number 2 as a value can be a coordinate. Number 3 as a value can be a coordinate. Number 4 as a value can be a coordinate. And these coordinates can be associated with a magnitude of 0. I know that's very tricky to think about, but let's try this. In M theory, string theory, there's 11 dimensional coordinates. So I'm going to use the letters A, B, C, D, E, F, G, H, I, J. No, that's confusing. I'm going to use Z, Y, X, W, U, V, T. I can't do the alphabet backwards. Okay, we'll just use the beginning letters. If we're going to go A, B, C, D, E, F, G, H, I, J, K, L, K. So from A to K, you have 11 dimensions. Each one of those dimensions from A to K is going to be a coordinate. So coordinate A is going to be 0, coordinate B is going to be 0, all the way to coordinate K. That's 11 dimensions. That is what M theory suggests that our universe operates on. We operate on 3 of those dimensions, let's say A, B, and C. We operate on length, width, and depth as geometry is concerned. The 4th dimension is recognized as time, but it's not associated with geometry. So we're going to recognize A, B, and C because I'm unable to do the alphabet backwards, I'm sorry. We're going to recognize A, B, and C as length, width, and depth.